Hello. So thank you for introduction, and the presentation will be in Latvian, but I will talk in English. So what I'm going to talk about is about most popular or most kind of common vulnerabilities in applications developed here in Latvia by local developers. The statistics comes from last 2-3 years of actual pen tests where we have done it for clients, and I excluded lower risk problems, and basically it's the problems you will see it's mostly kind of high risk. The problem with this kind of presentation is that I cannot disclose examples of those particular systems we tested. So the examples I will show you will be from some general systems taken from internet. So basically it's kind of like more or less, some of them are fixed at this moment, some of them probably are not. And the statistics will be based on OWASP top 10 year 2013, which looks kind of like this one. It's kind of injections, broken authentication, and so on. So I will talk about all these later on, and we'll add 2 additional ones. Okay, I can skip that one, and I will start with injections, which is kind of surprising results that 41% of the systems had SQL or some other kind of injections. SQL injection is the most common one. We have seen a couple of XML injections and things like that, but so basically, if you don't know what does that mean, what is the SQL injection, it's kind of like backdoor access to database on all data stored in the database, or sometimes you can execute commands on the systems and things like that. So 41% is pretty high number. Most of them, luckily, are blind SQL injections. So it's not possible to see all the data from database on the screen on the web page, but just kind of like you have to dig for it. And other thing about SQL injections, it allows you to get to the user accounts and user passwords, and it kind of like from statistics, it was 15% of the systems have stored the user passwords not in very secure way, in clear text or kind of like just with protected with hash. This is example of kind of like if I'm started to talk with passwords, it's not about web developers, but about one other system which had quite a lot of user accounts and passwords. So this is top 10 of Latvian passwords. Not in the right kind of order, but still, when I first saw this kind of like data, I was kind of surprised that word "son" is mentioned here 3 times, actually. And if we talk about quality of the passwords, 70% was kind of like brute forceable by dictionary attack. The database was quite large. The other thing is problems with authentication and session management. So 70% of the systems had those problems. Most of the problems come from basically cookie management and kind of like session identificator management. All you have to do from developer perspective is set 2-3 parameters when you are creating cookie and change the cookie value after login. But as we can see that 44% of the systems didn't set those kind of like required parameters when creating cookie, and third of the systems didn't change the value of the cookie after login, which is a technical term, session fixation, and it's kind of like a more or less serious security vulnerability. Other problems which are kind of like not as seen as often is that after you hit logout from the system, the session is not destroyed, and you can still access the system with the kind of like as authenticated user, more or less, with some kind of like tweaks. If someone is using kind of like complicated authentication scenarios, it's almost always there's some kind of problems. So. And of course, mobile applications, almost all the mobile applications we have had a look at had some kind of problems with authentication, which basically boils down to password storage and authentication information storage on the device. So in simple terms, it means that basically, as the application developer, you want a good experience for user. Basically, you want when he opens application, automatically be in his account. So, and for that reason, many of them are storing a username and password on the device, and which is kind of like easily accessible by third parties, or more or less easily accessible. Okay, there are some slides about this session things. This is an example from kind of like internet portal Mana Balss. It's kind of like quite very good example in that case that it demonstrates not only session management problems but other problems as well. This is how it was done some 2 years ago. Basically set cookie without parameters, which means that the cookie could be easily stolen. And after login, the same cookie value. So it means it has this other thing which is called session fixation. After kind of like half a year ago, they made some changes in the application. Here you can see they are creating cookie and adding one additional parameter, which is kind of like a good thing, but still missing other one. And session fixation, as you can see, the cookie value doesn't change, it's still there. Before, when making this presentation for this event, I went to check this how they are doing. Maybe they kind of like would do it, and still, when creating the cookie, there was missing was missing secure parameter, and session fixation still was kind of like issue. This is kind of like how they are creating cookie right now. If of course Mana Balss is kind of like project with where there is no lot of money for them and they are not making money. Basically, it's kind of like so maybe the developers which has kind of like a good startup story Infogram, one of the Latvian applications which is kind of famous for making graphs. I suppose they have some venture capital funding and have money for development, and still when they are creating cookies, basically HTTP only, which means accessible by JavaScript, not accessible by JavaScript is okay, but still no secure parameters, so the cookie is transmitted over unencrypted connection. But maybe they are using only encrypted connections, but no. They are basically answering your query on HTTP protocol and sending this cookie over. So if you are accessing this Infogram, for example, from public Wi-Fi and have been logged in, so everyone who basically may have ability to see this cookie and then log in as you. Cross-site scripting. Almost 60% of the systems had cross-site scripting vulnerabilities, which kind of like almost 50% had dynamic cross-site scripting, and third had permanent cross-site scripting. The dynamic is more or less that you have to send something to user to execute the script in his browser. Stored or permanent is that you are storing this JavaScript in application itself and basically waiting for the user to come into the page or yes. How does it work? And where are the risks? This is a kind of like example from training system and kind of like guestbook application and things, something like that. And this particular message ziņa 2 has additional JavaScript code, which is kind of like not seen from normal browser, and which sends this session cookie to me. And how could I? This is a small video. Ah, no, it doesn't play. Oh, it works. How easy is to use this session cookie to basically log in as a user? Of course, if you are doing this session management in kind of more or less secure way, adding this HTTP only flag, this kind of attack won't work, but still I can harvest this cookie using free Wi-Fi or some other means. This is kind of log file where this cookie is stored. Kind of like very hard to understand if you just look at it, but it's URL encoded. But the actual cookie value is, my guess, is somewhere here. Yes. What I'm gonna do is I'm copying it and pasting in the browser as my cookie. So if we are talking about these previous applications, you can harvest those things and kind of like do this similar kind of attack. Other thing, while you are watching this video, basically kind of like good example is Mana Balss, which kind of like demonstrates technical capabilities of many developers that they're kind of like trying to fix something, are adding some kind of fixes to their systems, but sometimes they don't really work. So Mana Balss is fixing the session management for last 2 years, but still haven't done that. So I mean, with modified cookie. Other thing, direct access to some objects. This is example from real internet. I am not hiding the name of the company who did it because as I found out, they kind of like after a year and a half fixed this particular vulnerability. But more or less is that you have 33% of the systems didn't protect some of the assets, which means if you are, for example, applying for a job, posting your CV on the company website, it might go to web server, to publicly accessible directory, and everyone who could guess the name of your CV file may kind of like look at it. Or like in this example, you are buying book in the internet shop, and when you kind of like want to pay, they are preparing you invoice and sending it by email. Link to the invoice, you click on the invoice, oh, you can see invoice. And in this case, there was no authentication, and if you kind of like go over these numbers, you may browse through all the kind of like invoices who those guys written out, and you can see who bought and what bought, where they are living, what's their phone number. Sometimes people are giving their personal code and things like that. So 70% of the systems has kind of like some kind of configuration problems or sending data which should be encrypted over unencrypted channels. This is example, which is not technically about example about configuration problems, not technically about web developers, but more for us system administrators. And to be honest, I really don't know how to configure a MikroTik router to do things like this. I'm just connecting to web address without logging it, which is kind of like a MikroTik router. Web administration, waiting, and without logging prompt. Maybe you know how to do it, I don't know. Other thing, again, monoballs. When you look very carefully, there is bank authentication. I'm logging into monoballs using internet bank, SEB. And at some moment, for whatever reason, SEB is sending basically my authentication token, basically information about me, and over an encrypted channel. So if I'm doing it from public Wi-Fi, someone could intercept things like this particular token and kind of like log in as me, and which is not very good thing. Unencrypted data basically here example of customer portal in Ventspils Siltums, which is kind of like badly configured that you can if you live in Ventspils and want to access I think some user information, so basically some billing information, you can register and log in, and this should be kind of like encrypted, but it's not. The same, again, it's kind of like local government, maybe they don't have money, it's kind of like expensive to buy a certificate for 70 euros or for a year. Maybe startup companies, which this particular one has raised $250,000, maybe they have the money for security certificate to provide SSL encryption. But no, if you are logging into their applications, they are sending your username and your password in clear text. Since it's kind of like error messages. When applications leak error messages, it sometimes may help hackers to kind of like stage next step in an attack. It's kind of like almost 20%. This is example, for example, for this live internet system, not fixed for a couple of years. When you write something wrong in this parameter, it just gives you answer like this, which is kind of like telltale signs that this script has some serious security problems. So what would be next thing to do? Next thing to do probably would be browse the file system. It's kind of like if you give too much information, it might lead to kind of like exploiting. My guess is that you cannot do any serious damage with this kind of security problem, but still it's kind of like, it's, by the way, who understand Latvian, it's kind of interesting name of the system, host name. Authorizations problems. The most famous here in Latvia was VDDS, which was a couple of years ago. But they are still kind of like widespread, 41%, and the most common actually is that in administration interfaces, when they are showing user only things they are allowed to do, and if there is some restricted functionality where he has should not be doing, they just kind of like not showing it to him. Or for, in general, public. There have been administrative interfaces for web systems where basically they have some kind of login interface, but if you know the name of the script, which is kind of like behind this login screen, you still can execute it as a regular user. Cross-site request forgery, which is kind of like actually it's very widespread. It's kind of like more closer to 90%, not 30% like in this case. But in most cases, you cannot do a real damage with it. So what is cross request forgery thing? Basically is that you have a user who is using some, for example, internal system. He has username, password. He has logged in there, and there is some external system. What attacker could do is put some specially crafted code, which is kind of like very simple here, on the external website where user might be visiting while logged in here. So when user are visiting this one, his browser automatically executes script on kind of like opens image or image on this server and kind of like executes functionality, which is a very this attack thing is very hard to kind of like see, and because everything user is doing in this system is kind of like legal actions, which is what is he's doing each time. So this is example. Maybe you know there is in Latvian forum named CSRF. My guess is it is kind of like most popular internet forum for women to socialize between themselves. So what I'm gonna do, I will change my email address in the user profile, not knowing basically by visiting other site, which is kind of like, because this particular forum is kind of like vulnerable to this cross-site request forgery thing. You can see my email address, agris.krusts@gmail.com. Later it will be a bit different. I don't know why I'm clicking there, but and this will be the website I'm visiting, CSRF CSRF. And basically that's it. We have changed the email address in the user profile at this moment. I may go check it out. It's kind of different. So no warnings that I'm changing something or confirmation, things like that. So it's 30% of the systems, more or less. Public vulnerabilities, it's kind of like 15%. Publicly known vulnerabilities, but it usually depends on the time of the test, and usually clients don't ask us to test WordPress installations. So for that reason, the actual situation in Latvia might be a bit worse. Another thing which is kind of like out of this OWASP top 10 is other thing actually is management of cache in the browser, which is kind of, if you are a web developer, for usually if user are watching, are seeing some kind of like restricted information on his browser, which should not be seen by other parties, you should send additional header saying that please do not cache the thing. And this header is usually quite often missed in 20% of the systems. They're kind of like not sending this header, and this information, which kind of should not be publicly available, is saved on computer. And if you are using those systems from, for example, from public computers, which are in libraries, for example, it's accessible to others. Fortunately, banks are more or less secure. They are kind of like knowing this kind of problem and not vulnerable to them. And last thing, what do you think? How much, in how many cases we were able to get to the operating system, to get the shell on the system? Your guess. Yes, really. You guessed it right. In 10% of the cases, we were able to get the shell on these systems.
How many of these websites or apps were self-hosted? How many of them were actually even hosted on a shared hosting?
Usually we are testing in the like big systems, and they are more or less self-hosted. But I cannot answer in particular terms. Majority are self-hosted, but and this is kind of like overview slide. Questions?
Yep, please. Questions?
So those numbers. The question is: do you think you have found all the vulnerabilities there, or probably that's at least this much?
At least this much, yes. It's not possible to find. Usually, not possible to find all the vulnerabilities, but it's the situation in general internet would be, my guess, a bit worse because the people who are testing these systems are kind of more or less interested in security. So.
Yeah, sure.
You mentioned two cross-site scripting variants. It was reflected and stored. What about third possibility, DOM-based cross-site scripting?
Yes, it's kind of. I didn't mention it here because we were not kind of like differentiating it for the whole duration. But now it's kind of like it's more or less very similar to reflected cross-site scripting. So it's very quite common.
From my side, maybe the last one. When you found the vulnerability and you informed the developer or the organization who is owning the software, actually how fast they are applying some patches and changes?
This is a thing I cannot comment.
Okay. Yeah, but it's usually takes long time or
it
not.
Depends, but the problem is that we can like the clients are protected by confidentiality agreements, and I cannot really answer this question.
Okay, clear. Thank you.
Okay, thank you.
Yeah.